Good morning, students. So in the previous class we discussed about the steps in the sampling design. Okay, I repeat, what are those steps? One is the have the inverse. Okay, we need to decide, and we should know the meaning of the inverse as a researcher. And second step is the sampling units. Okay, we should know what are sampling units. And third, the source list, the preparation of the source list for the research study, and the size of the sample decision. Okay, how many samples and what will be the sample size, that's also to be estimation is most important. And also the parameters of interest or the parameters of interest for the research study, that also we have discussed what are those, then example. And also the budgetary constraints for the sample study or the data collection, that also to be considered. And also the sampling procedure has also to be decided before we go for research study, that is called a sampling design. So these are all the factors to be considered while designing a sample. Next, and also we discussed about the sampling procedure. That is, we come across two types of error. One is known as systematic bias. Systematic bias. Another one is sampling error. How to reduce a systematic bias? Okay, and how to reduce the sampling error? That also we have discussed extensively yesterday. Well, we also discussed about the characteristics. Also discussed about the characteristics of good sample design. Okay, so there are 5 characteristics. Okay, the representative of the sample and the small sample error the research design should have, and the research budgetary constraints, the sample design within the constraint, and the bias able to control or reduce, and the error, sampling error had to be also to be reduced. The sample design should be pursued with that. And the last one, the whatever the study we carry out on a sample, that should be truly representative of the inverse of the population. So like this we studied the different characteristics of the sample design. Today we'll discuss about the different types of sample designs. Different types of sample designs. There are different types of sample designs based on 2 factors. They are categorizing these sample designs based on the 2 factors. One is representation of the bias and the element selection technique. Okay, note down these 2 points. The sample design is being categorized based on representation of the bias and the element selection technique. On the representation bias, the sample may be probability sampling or it may be non-probability sampling. Okay, then what is probability sampling? Probability sampling is based on the concept of random selection. Based on the concept of random selection. And the non-probability sampling, and the non-probability sampling is non-random sampling. Okay, these 2 classes based on the representation basis. Okay, One element selection bias. Selection bias. The sample may be either unrestricted or restricted. Okay, on the element selection basis, the sample may be either restricted or unrestricted. When each sample of the element is drawn individually from the population at large, then the sample so drawn is known as unrestricted sample. Okay, whereas all other form of sampling are covered under the term restricted sampling. The following chart exhibits the sample design as explained above. Okay, so with these two category of sampling design, okay, you refer the figure 4.1 of the Kothari book. Okay, so the first column represents the classification based on the element selection technique, and the second column represents the classification based on the representative basis. So as already defined, based on the representative basis, it's going to be classified as probability sampling and non-probability sampling, and I give the definition now. Well, the second one is element selection technique. So in this, there is a restricted sampling technique and unrestricted sampling technique. For this also, I gave the meaning and definition of these two processes. Understand? So now we discuss the non-probability sampling and the probability sampling with respect to representation basis. The non-probability sampling is the sampling procedure which does not offer any basis for estimating the probability that each item in the population has of being included in the sample. Okay. Non-probability sampling is also known as by the different names such as deliberate sampling, purposive sampling, judgment sampling. Okay, note down clearly. The non-probability sampling is also called as deliberate sampling, purposive sampling, and judgment sampling. Okay, in this type of sampling, items for these samples are selected deliberately by the researcher. His choice concerning the item remains supreme. In other words, under non-probability sampling, the organizers of the inquiry purposefully choose a particular unit of the universe for contributing sampling on the basis that a small mass that they so select out of the huge one will be typical or representative of the whole. For instance, if economic consideration of the people living in a state are to be studied, a few towns and villages may be purposefully selected for intensive study on a principle that they can be a representative of the entire state. Thus, the judgment of the organizers of the study plays an important part in this sampling design. Okay, so they purposely select some of the states and districts and the villages. Okay, and they study and they pass the same information to the whole population. Okay, in such design, the personal element has a great chance of entering into the selection of the sample. That's what the major difference between probability sampling and non-probability sampling. In the non-probability sampling is left to the choice of the researcher. So the researcher can select anyone if he is interested in particular state, he can choose. Okay, for example, take the consideration of the spread of corona. Okay, the whole almost all states are undergoing an effect of corona. Okay, so there are 24 states in the Karnataka. Out of 24 states, around 10 to 12 states have been affected very less, including Karnataka state. Okay, the corona effect is very less compared to the other states of the country, that is India. So if the researcher is being allowed to study about the corona, certain characteristics or the corona effect on the population, about the age, about the gender, about the any parameters. Okay, so the parameters of interest the researcher can design. And while selecting the state, the researcher can bias that Karnataka is selected and the few states which have been not affected for much, so he can select those states and study, and he can represent the whole other states of the country. It is not true, because here the non-probability sampling technique has been used by the researcher, not on the basis of the probability sampling. So that's why, so the personal element has a great chance of entering into the selection of the sample. Okay, the investigator may select a sample which shall yield results favorable to the point of view, and if it happens, the entire inquiry may get vitiated or violated the true value. Thus, there is always a danger of bias entering into this type of sampling technique. But the investigators are impartial, they work without bias and have a necessary experience, so that they take the sound judgment. Okay, the study must include such that if you go the probability sampling, it includes the samples of the there's some states who have been occurred very severely, and some states which have occurred medium, and some states which have been affected by the corona less. So like that, the mixture, okay, that is a representative of the whole population of the country in the probability sampling. Okay, so if the researcher is non-partial, then the study gets proper results or the good results or the expected results. Okay, if the researcher is impartial, but we cannot trust. Okay, so these are the this is known as non-probability sampling. And next comes to the probability sampling. So the probability sampling is also known as random sampling. Probability sampling is also known as random sampling or chance sampling. It's also called as chance sampling. Chance sampling. Under this sampling design, the every item of the universe has an equal chance of inclusion in the sample. Equal chance of inclusion in the sample. It is so. It is so. Uh, it is so to say a lottery method in which the individual units are picked up from the whole group, and not deliberately, but some mechanical process. Okay, in this sampling, here it is a blind chance alone that determines uh, whether one item or the other items are selected. The result obtained from the probability of random sampling can be assured in terms of the probability. So we can measure the error of the estimation of the significance design or the deliberate sampling design. And random sampling ensures the law of statistics. Okay, it's based on the law of statistics, the probability sampling. Uh, Regularly, the composition and characteristics has a inverse, and this is reason why random sampling is considered as the best technique of selecting a representative sample from the universe or the population. Okay, if anybody interested to have such kind of sampling technique in your research study, better go for probability sampling, okay, rather than the non-probability sampling. Choose probability sampling. You will get a very good and accurate results for your research study. Okay, so the random sampling from the finite population refers to that refers to that method of sample selection which gives each possible sample combination on equal probability of being picked up and each item in the entire population to have an equal chance of being included in the sample. Okay, every item in the sample, every item in the universe of the population have got equal chance of included in the probability based on the probability sampling technique. This applies the sampling without replacement. Okay, once the item is selected for the sample, it cannot appear in the sample again. Again, in brief, the implications of random sampling. The first one, it gives an element, each element in the population, an equal probability of getting into the sample, and all the choices are independent of one another. Okay, and it gives each possible sample combinations on equal probability of being chosen. So because of these two principles, the probability sampling plays a very important role, and it is an accurate technique which is being used for sampling study. So then we need to discuss about how to select a random sample. With respect to this question, how to take random sample in the actual practice is, okay, we can take a random sample in relatively easier way without taking trouble in enlisting all possible samples on the paper slips as explained in the book. Okay, that is, each possible sample on the slip paper. So what we do is we need to write the in this we need to take a random sample in the actual practice. We take an example, a simple case like one above, that is, write each of the possible sample on the slip of the paper and mix those slips thoroughly in a container and then draw on the lottery basis, either blindfolded or by rotating the drum or by any other simple device. Okay, such proposition is obviously impractical and it is altogether impossible in the complex problem of sampling. Okay, so the writing on the slip and mixing and rotating or shaking and randomly shaking and picking some of the, it's also a probability sampling. Okay, it has got every chance of picking an each element in the sample. Fortunately, we can take a random sample relatively easier with taking trouble into enlisting on the paper slip as explained above. Instead of this, we can write the names of each element of the finite population on the slip of a paper, put the slips of the paper so prepared into a box or a big or a mix thoroughly, and then draw a required number of slips for a sample one after the other without replacement. Okay, so in doing so we must make sure that in successive drawing of the each remaining element of the population has same chance of being selected. This procedure will result in the same probability for each possible sample. We can verify this taking the above example. Okay, this a really representative of an experiment of probability sampling. Okay, so for relatively complex problem, okay, there are many researchers or the statistician, Tippett, Yates, Fisher have prepared a random number tables, okay, for the complex problems. Okay, so we take an example. You refer the book, if you refer the page number 61 of the Kodari book, okay, the sampling design chapter. Okay, he has selected some group of numbers of, absorbed from the statistical random number table generated by the Tippett uh, statistician. Okay, so the table has been given. Okay, we need to get the numbers from 3001 to 8000. Okay, the number selected should be above 3001 and below 8000 number. Okay, a sample size of 10 is to be selected. Okay, so if we ask to select 3001 to 8000, okay, so the randomly by the random number table, how to get based on the probability sampling. Okay, you refer that table. Okay, you move your search. Okay, read the table from the left to the right, starting from the first row itself. Okay, to obtain the 10 numbers, those are within 3000, above 3001 and below 8000, are the 6641 3992 7979 5911 3170 5624 4167 7203 5356 and 7483 as per the random numbers given by the Tippett in the book. So this is how the random samples have to be generated based on the random number table. This is what the procedure is being adopted. Okay, so then this all discussed about the probability sampling and non-probability sampling. Okay, so now we'll discuss about the uh, complex random sampling design. Okay, so the complex random, okay, the sampling design supposed to be called as complex, that is called as complex random sampling design. To study about this, okay, we need to have some popular complex random sampling design methods are there. Okay, so what are those methods? The first method is known as systematic sampling. Second method is known as stratified sampling. Okay, the third method is known as the cluster sampling. Fourth method is area sampling. Fifth method is multi-stage sampling. Okay, and sixth method is sampling with probability to use, and seventh one is sequential sampling. Okay, these are all the different sampling, complex sampling methods. Okay, this then what do you mean by systematic sampling? In some instances, most practical way of the sampling is to select every ith atom on the list. The sampling of this type is known as systematic sampling. Okay, so there is a set of population, okay, or there is a sampling frame, okay, where a lot of objects are being kept. So if I select every ith item in the population, say for example we have around 1000 components in a tray. Okay, instead of that, okay, assume that it is a tray. So if you start count 1, 2, 3, 4, 5, 6, okay, the component which is being selected is taken as one component in the sample. Okay, then I need to choose the every ith item. Say ith is nothing but every 10th item of the count. Okay, I need to pick up from the tray second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Okay, keep it aside. Okay, now there are two pieces in the sample, the first one and the 10th one. Again count in the tray. Take out 11th, 12th, 14th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th. Pick that 20th piece and keep it in the sample. 3 pieces now in the sample. So like this, the every 10th item of the count is to be taken as a piece and is to be kept in the sample. Okay, assume that sample size is 10. So till you get 10 pieces at every 10th item in the container is to be picked and is to be kept aside in the sample. This is known as systematic sampling. Okay. So systematic sampling has 2 plus points. It can take as an improvement over the simple random sample in as much as a systematic sample is spread for every evenly over the entire population. It is the easier and less costlier method of sampling and can conveniently used even in case of large population. These are the 2 benefits of this systematic sampling. Then second one, stratified sampling. If the population from the sample is to be drawn does not constitute a homogeneous group, if the components which are in the tray, if they are not homogeneous, not similar with each other, the stratified sampling technique is generally applied in order to obtain the representative of the sample. Under stratified sampling of the population is divided into several subpopulations that are strata. Okay, dividing the population into subpopulation. Each subpopulation is called as strata. And then we select the item from each stratum to constitute a sample. So each stratum is more homogeneous than the total population. We are able to get more precise estimates for each stratum, and by estimating more accurately each of the component parts, we get better estimate of the whole. In brief, stratified sampling results in more reliable, detailed information. Okay, so you are expected to know what type of study you are performing, whether the container consists of a homogeneous components, apply systematic sampling. If the container consists of non-homogeneous components, you cannot apply systematic sampling. You must apply stratified sampling. So as a researcher, you should know what type of sampling procedure is to be selected for what type of study. No, you should know the knowledge, you should have a knowledge about all these methods. Then only you are able to apply which method for what situation. That is important for the researcher. Okay, otherwise you will land up with the wrong answer. Okay, the example which I have given now, if the container is non-homogeneous, if you apply systematic sampling, you will land up with the wrong answer. So if you had applied the stratified sampling, that is the right application of the sample. Provided you have the knowledge, you will apply, otherwise you will not. This next sampling, third sampling, is cluster sampling. So the total area of the interest happens to be big one. The convenient way in which the sample can be taken into divide the area into number of smaller non-overlapping areas. Okay, and randomly select the number of these smaller areas, okay, which are called as clusters, with the unlimited sample consisting of all units in these sample areas or clusters. Okay, so if the area is very big, okay, you divide those areas into smaller areas, into smaller non-overlapping areas. Okay, so those smaller areas are called as clusters. Okay, so the India consists of 24 states. Okay, they have identified 24 clusters. Each state we can call as a cluster. Okay, so this is called as a cluster sampling. Whole India can be divided into 24 states called as clusters. So for this study, you identify certain clusters, say for example, north zone, south zone, east zone, west zone. Okay, so there are 4 zones. So we need to study about the whole Indian population. You select 2 states at the north, 2 states at the west, 2 states at the south, and 2 states at the west. So if you select like this, totally 8 states are being selected instead of 24 states. Okay, and another 2 states at the middle of the country, 10 states. So you study the conduct you study these clusters, 10 clusters, and you can same information holds good for whole population of the Indian country. So this is known as cluster sampling. Okay, then area sampling. If the clusters happen to be some geographical subdivisions, in that case the cluster sampling is better known as area sampling. Okay, the cluster happens to be some geographic subdivisions. Okay, so geographic subdivision based on the geographical characteristics. So if you divide these clusters, then they are called as area samplings. They are called as area sampling, in which the sampling unit representative of the unit based on the geographic area and distinguished as a area sampling. Thus, the plus and minus points of the cluster sampling are also applicable to the area sampling also. Then fifth one is multi-stage sampling. Okay, nothing but the sampling is carried out in different stages: first stage, second stage, third stage, like that. Okay, so the whole country with respect to the corona, so the first stage precaution was being taken by Prime Minister Modi ji is that the 21 days lockdown, that is the first stage. So he observed the impact of this corona on the population in the every state, and he spoke or video conferencing with all chief ministers of the states, and again he implemented second stage lockdown based on the opinion of all the chief ministers of the state. So that is the second stage. So like this, the implementation of the sampling is to be taken out based on the stages. That is called as multi-stage sampling. So the second stage is up to 3rd May. We don't know. Okay, again the Prime Minister Modi ji can go video conference, and also he collect some statistics from all this data about the virus affected people, how many of them have died, how many of them have recovered, what is everyday findings of the corona cases in the states. So all the things again he study in the second stage, and he can take decision about whether to continue third stage of lockdown or not. Okay, so the same way the multi-stage sampling for any selection procedure in research, okay, to be carried out at the different stages. Okay, so in this we can call it as I'll give an example. Okay, one more example where we can most of the industry people will know this. Okay, so what happens in the first stage sampling? So they randomly pick certain samples from the manufactured components from some machines. Okay, they test the samples, they randomly pick up. So assume that the container, in the first 4 hours of manufacturing, so we have produced around 100 components. Out of 100 components, randomly I will select 10 pieces. Okay, out of these 10 pieces as a sample. Okay, out of this 10 pieces sample, I inspect all these 10 pieces. I'll inspect all these 10 pieces. If all these 10 pieces being inspected, if all these 10 pieces found okay, the whole lot is going to be accepted. Assume that if anything goes defective with the 10 pieces which have been selected, assume that. So then some rejection takes place in these 10 pieces, things that we need not reject the sampling for the second stage sampling. That is called a second stage sampling. Again, randomly we pick 10 pieces from the existing lot. If that lot does not contain any defective, then whole lot is produced lot is going to be accepted. Okay, that is second stage sampling. So the first stage sampling, second stage sampling, so like this it could be performed based on various stages of the sampling, is called as multi-stage as sampling. Okay, then the sixth one is the sampling with probability proportional lot size. So in this case, cluster sampling units do not have the same number of approximately the same number of elements. So it is considered appropriate to the use of random selection process, where probability of each cluster being included in the sample is proportional to the size of the cluster, is called as sampling with probability proportional to the size. Okay, then the last one is sequential sampling. So in this, the sampling design is somewhat complex sample design. The ultimate size of the sample under this technique is not fixed in advance, but it is determined according to the mathematical decision rules on the basis of information yielded as the survey progresses. Okay, this is usually adopted in case of the acceptance sampling plan to context to statistically quality control. So when particular lot is to be accepted or rejected on the basis of single sample, okay, it is known as single sampling. Okay, that is nothing but from a lot, okay, select some 10 samples. If 10 samples found to be okay, then whole lot is accepted, all remaining 90 pieces are accepted. Okay, that is called as single sampling. So when the decision to be taken on the basis of two samples, then it is called as double sampling. And in case of the decision taken on the more than two samples, it is called as this is called as this is more than two sample numbers, and it is known as multi-sampling. So but when the number of samples is more than two but neither certain nor decided in the advance, okay, this type of system is often referred to as sequential sampling. Okay, once again you listen to this video carefully and understand the concepts of all sampling methods which has been given. Okay, take down the question. So identify different complex sampling designs or the methods, and explain briefly with example each complex random sampling design. Bye. See you. Take care.